All right, your homework for 4.5. In 4.6, we are going to be taking a further look at our rational functions and analyzing them, which means we are going to be describing all the features that go with those types of functions. So, as a refresher, your ready part of the homework is involving just some graphs and identifying the features of just these graphs in particular. So that way we can refresh our memory for the rational functions. So just a quick run through on some features that you really should be describing are max and mins, so the highest point and the lowest point. Domain and range. Don't forget, domain is your x values. Range is your y values, your x-intercepts, your y-intercepts. If your function is increasing or decreasing, and anything else you can think of that might help you maybe prepare for our next section. So let's just do this. I'll do number 1 with you, and then you guys can work on the rest. This function does have a max. It has a max at the point -5 and 5. The minimum, it doesn't have one. The reason there is no minimum, this is an open circle. It is never going to get to the point 2, -6. It's going to get really close, but it will never reach it. And remember, there's an infinite amount of space between one point and another. So it'll keep getting smaller and smaller and smaller and closer and closer and closer, but it is never going to get to the point 2, -6. So there is no minimum. Domain is your x values. So from here, this is the furthest left x, and it goes all the way to here. Well, that x value is -5. It gets a bracket because it is a closed circle. And this x value is 2, and it gets a parenthesis because it is an open circle. Range is your y values. Here is your bottom y value at -6 with the parenthesis up to 5 with the bracket, again, because of the open and the closed circles. X-intercept, it's really close to -2. Doesn't look like it's quite -2. It could be an error by the book where they thought maybe it was close enough. I'm going to say that this is about -1 point, maybe 8. And then, so there's our x-intercept. Here's our y-intercept. And I'm going to say that that is close enough to -3. And this function is decreasing. It's from, if I read this from left to right, in behavior I don't need to worry about because there are no arrows here. Let's see. You might think of some other things that you might want to talk about, but I'm going to just stop with this. And again, this shouldn't be very, very difficult. It is review. Take your time. If there's anything you have a question on, make sure you write it down so you can ask me in class or come in and see me. Now let's move on to the set. For each of the given functions, determine the output or range value that is approached by the function as x approaches positive infinity and negative infinity. I am going to, because we really haven't talked a whole lot about in behavior, so I'm going to have you guys check this in Desmos. So in Desmos, if I were to type this in, actually let me go ahead and bring up Desmos. I'm going to have to type this in. There we go. Okay, so my equation was x minus 1 and x plus 2. Please make sure you do use parentheses. Actually, let me not do that one. Let me go ahead and do 8. x cubed plus 2x squared plus x. When you're typing that in, you need to put the entire numerator in parentheses. So x cubed plus 2x plus x. X cubed plus 2x. Whoops, I forgot the 2. Squared, and then plus x. Let me double check that that's correct. X cubed plus 2x squared plus x, and then all over x plus 1. And then I'm going to come out here, get rid of the keyboard, and then I'm going to put divided by, I don't know where this extra set of parentheses came from. There we go. Divided by, now I forgot what it was, x plus 1. So here is this rational function, and you're probably wondering, why is this a parabola? It is a parabola because if I factor out an x, I am left with x squared plus 2x plus 1, which is factorable. So I would have x times x plus 1 all over x plus 1. And a pair of x plus 1's cancel, which leaves you with x times x plus 1. So that is a parabola. So as I'm identifying the end behavior, because in this case, stuff canceled, it made it nice. And another one, it might not look like this. This is easy to identify the end behavior. So this would be as x approaches negative infinity, f of x approaches infinity. It was an upward facing parabola. And as x approaches infinity, f of x also approaches infinity. If I do this with, if I look at 10, actually, let me show you guys the graph of 10. 10 has the exact same numerator as 8. The only difference is nothing is going to cancel. So I'm going to change that denominator from an x plus 1 to an x plus 2. So let me, x plus 1, x plus 2. So now you have a very different looking graph. And it's like, what the heck? Your end behavior, as I go through this, I am assuming, because I could be looking at this forever. Let me go back to the beginning. As x goes to negative infinity, it's not working too well. This one, the top piece is going out wider than this bottom piece. So this is also going to go as as x goes to negative infinity, this is going to infinity. As x goes to positive infinity, this piece right here is also going to positive infinity. It looks weird. Don't worry, we're not going to graph anything quite like this. This is really just for end behavior. So this one, as x went to negative infinity, f of x was going to infinity. That last side was going up. That's all you need to look at, that the graph was going up. It had something like this, and then it also had something that looked like this, which is possible, you guys, with these rational functions. So negative infinity, infinity, positive infinity, infinity. As x goes to infinity, f of x also goes to infinity. So use Desmos. Hopefully that will help you there. If there's anything you're stuck on, you can always ask me later. Odd and even functions. So this was really our focus in class today, was discussing when you have an odd or an even function. Remember, evens are symmetric. to the y-axis. Odds are symmetric to the origin. Everything else is neither. I don't want to give you too many hints here because there needs to be some discovery. What I would like you to do, we're going to put 13 and 14 together. I'm not worried about you guys drawing the graphs, though it might help you if you use this space down here to make a rough sketch of the graph. For example, if I graph A, I know that that is a parabola because it's x squared, and because it's minus 3, it's down here at negative 3, and it opens up. Based on this graph, I know that this is an even function because it is symmetric to the y-axis. But if you look at C, you are going to see a quadratic. It will also be a parabola, but it may or may not be even. I want you, for all 6 of these, well, except for the first one, I would like you to think about what does the graph look like? And then from there, make an educated guess about if you think it is going to be symmetric to the y-axis, okay, then it's even. If you think it's symmetric to the origin, okay, then it's odd. Anything else is neither. Once you are done making your guesses, I would like you to graph them in Desmos. From there, you might need to change your answer. And it is okay to be wrong. On the ones that are even, find some similarities in their equations. The ones that are odd, find similarities in their equations. And then the ones that are neither, kind of think about, well, maybe why was it neither? Again, it's okay to be wrong here, but don't just guess to guess. If you need to check. Okay, you need to look at the graph. What does the graph look like for it to be odd, even, or neither? All right, let's move on. 15 and 16, you're drawing the function. So again, evens are symmetric to the y-axis, odds are symmetric to the origin. 17 through 20, finding asymptotes. So find the asymptotes. That includes vertical asymptotes and horizontal asymptotes. So your VATs and your HATs. Use your foldable. Use your notes. When you guys are looking at your vertical and horizontal asymptotes, don't forget your vertical asymptotes come from your denominator, but your denominator must be factored. You need to factor. I'm not factoring for you here. You need to be able to factor by now. And then horizontal asymptotes, don't forget, for those you are looking at your degree. Nothing else. That's all you need. Vertical and horizontal asymptotes. I'm not going to do them. You guys need the practice for this. In 21 through 26, you are solving. These are not hard. You're probably going to need a little bit more room, especially on the ones that you are going to have to factor. But solving includes finding the solutions. And on a graph, where do we find our solutions? We find our solutions at the x-intercepts. Now, all of these are rational functions. All of them. So what you are going to have to do, your first step, like we went over in class, you must factor and cancel. And then to find your x-intercepts, where are you going to look? You're going to look in the numerator. I will quickly refresh your memory about why you look in at the numerator for these. If I have a fraction and I want to get rid of my denominator to make this easier for me, I would multiply both sides by that denominator. Cancels on the side of the fraction. Well, x times 0 is just 0. So I'm left with x minus 1 and x plus 2. 21 was easy because it was already factored for you. Now I can solve for x. What you do have to make sure you pay attention to is the inequalities. And you have inequalities in 23 and 26. Anytime you see inequalities, that requires you to test on a number line. We have talked about this. You have had this on quizzes. I will go ahead and do number 23 with you. It's already factored. Don't need to cancel anything. So I'm going to take my numerator and I'm going to set this equal to 0. X minus 1 equals 0. I don't need the parentheses. And x plus 2 equals 0. So I get 1 and negative 2 to try. Well, for my boundaries. But with the rationals, you also have to pay attention to the denominator. And we need to remember the denominator can never equal 0. So what can x not equal? X cannot equal 0. So when I am testing on my number line, I'm going to put these three numbers in order. The 0, the 1, and the negative 2. Here's negative 2. Here's 0. Here's 1. The 1 and the negative 2 get an open circle because my inequality is not equal to. So open circle, open circle. The 0 gets an open circle because x cannot be 0 because that would be undefined. So the testing that you would have to do, and I'm not going to do the testing part, you need to pick a number on the left side of negative 2, so maybe negative 3. In between 0 and negative 2, so I'm going to say negative 1. In between 0 and 1, I'm going to say 0.5. And then greater than 1 is 2. So you're going to have 4 numbers. You have to plug back into the original. So negative 3 minus 1, negative 3 plus 2, all over 2 times negative 3. And it must be greater than 0. Let me change colors really quick. This is negative 4. This is negative 1. This is negative 6. So negative 4 times negative 1 all over negative 6. Is this greater than 0? No, it's not. It is positive 4 over negative 6. That is not greater than 0. So that spot does not work. Now you move to the next one, the next one, and the next one. You do need to make sure you test all sections. Nah, what the heck. Let's see, what time are we at here? It's getting long. I'll go ahead and finish. Let me get this out of the way. I'll go ahead and do the next one for you. And then that's the other two you guys can do. So I'm going to have negative 1 minus 1. And you could use mental math. You can use a calculator. Negative 1 plus 2 all over 2 times negative 1. Well, this is going to be negative 2 and positive 1 and negative 2. Is that greater than 0? Yes. This is negative 2 over negative 2, which is positive 1. So this piece works. That's one of my solutions. One of them. There might be a solution in the third spot, and there might be a solution in the fourth spot. So one of my solutions, one of them is from negative 2 to 0, and I write that in an interval with parentheses. So negative 1 was between the negative 2 and the 0. So you got 2 more to test and then go through and do that. Do you need to be able to do this? Yes. This is something you definitely need to be able to do. Practice this, please. Don't just finish with this. Take your time. Factor these 4 here. Factor and cancel, whatever you can. And things that you can't, then that is fine. All right, that wraps up the 4.5 RSG video. If you have questions, write them down, and I will see you tomorrow.